Here's practice quiz question number 3. General truth, meaning this is almost always true. An exothermic reaction must be preceded by an endothermic. Preceded means endothermic comes before. Endo first. That's what preceded means. So let's figure out why that's generally true. Creation of photons should be familiar to you. Here we have a quantum atom, n equal 1, n equal 2, n equal 3, etc. Electrons naturally are found at the lowest energy possible. That's ground state. If an electron is at ground state, no photon can be produced. So how do we get a photon? First, this electron needs to move to a higher energy level. I'll write it here in red as this is an excited state electron. So that would be an endothermic reaction. So first, energy boosts electron to an excited state. For example, n equal 1 goes to n equal 2. So that's what happens first. That's not a creation of a photon yet. After the electron is excited, that's the endothermic part. Then, second, the electron can fall, and that would be here, falling back to ground state. That means it's losing PE, losing potential energy, period. A photon is produced at that time. Is produced. Exclamation point. So it needed the potential energy in order to produce a photon. The photon energy equals the potential energy that is lost as the electron transition from n equal 2 to n equal 1. In this case, it goes back to ground state. Doesn't always have to do that. For example, if we were at n equal 3, you could go from n equal 3 to n equal 2, producing a photon, and still have potential energy to create another photon. So the production of the photon is the exothermic part. It could only happen after the electron gained potential energy in an endothermic process.